Hi everyone, I thought I would do an exemplars problem for today's number talk. Exemplars is a really great tool that we have at school. It helps us to have multiple entry points. There's usually a lower level, mid-level, and higher level on each of these problems. It's also a word problem, which sometimes a lot of students have trouble really figuring out where their entry point is and how to solve the problem. So you'll see today, this problem is about dog years. It is said that dogs are 7 years for every people year. Mason's dog, Shep, was born on Mason's 8th birthday. When Mason was 9 years old, Shep was 7 dog years old. In dog years, how old will Shep be on Mason's 12th birthday? Show all your mathematical thinking. Well, the strategy we use in class is that we read the problem at least twice when we're dealing with a word problem, just to make sure that we understand fully what the question is asking. So again, dog years. It is said that dogs age 7 years for every people year. Mason's dog, Shep, was born on Mason's 8th birthday. When Mason was 9 years old, Shep was 7 dog years old. In dog years, how old will Shep be on Mason's 12th birthday? Show all your mathematical thinking. So I thought about starting at the base level and then working my way up to more of the advanced level. Right now, I'd love for everyone to stop the video and try to solve this problem, and then let's come back at the end and see if we've matched any solutions. So the first place I thought about was creating a table. So Mason's birthday and Shep's age in dog years. So something in class we talk about on a regular basis is organization in math. If you're not organized, it's a very easy way to lose your math, get confused, not get the correct answer. So really being organized is going to help us in any mathematical situation. So Mason's birthday, he was 8 years old. Shep was 0 years old. Then on his 9th birthday, he was 7 years old. Then on his 10th birthday, Shep was 14 years old. On his 11th birthday, Shep was 21 years old. And then on his 12th birthday, Shep was 28 years old. Excuse me. So at first, 8 to 0, not making the relationship, then 9 to 7, then 10 to 14. We see moving on here that we're just going to be adding 7 from this point forward. So adding 7, so going from 0 to 7 is 7, and then another 7 is 14, another 7 to 21, and another 7 to 28. So adding 7s as we go up in ages with Mason's birthday helps us to see the age in which Shep is going to be. One of the next entry points that we could use is a number line. This is an open number line. The kids are familiar with them. So if we have on top Mason's birthday and then Shep's. So 8, so we know when he goes up to 9, we see 7. So again, adding that 7 piece. So going up 10, he's 10 years old. Shep is 14. Then going up to 11, Shep is 21. And then going up to 12, Shep is 28. So we see adding 7s each time. Now we can also talk about the rule of math here. We've talked about rule of math problems several times in class, depending on what the rule might be that they're looking for. So P is people years. D is dog years. So thinking about how we have 7 dog years for every people year, so 7 times P for people years equal the number of D dog years. So something we talk about in class is called CSRQ, complete sentence restate question. So in this situation, the question stated, if we go back, in dog years, how old will Shep be on Mason's 12th birthday? So thinking about CSRQ, how could we restate that question with the answer in it? In dog years, how old will Shep be on Mason's 12th birthday? So on Mason's 12th birthday, Shep will be 28 years old. So our CSRQ statement, taking the question and restating it with the answer included. Also thinking about the justification pieces required on ACT Aspire, students who are looking for a buy-in point, they could always have pencil and paper during ACT or MAPS during the math section. So they could create the table, they could create the number line. Okay, neither one of these things could be written out really on ACT Aspire on the computer, but they could definitely write out the rule, okay, and the mathematical equation. So we know that that is 7 times 4 equals 28. Now we have our CSRQ statement. On Mason's 12th birthday, Shep will be 28 years old. And then for justification, I know that Shep will be 28 years old because 7 times 4 equals 28. So that response would cover the justification piece that they're looking for on the ACT Aspire. I hope you enjoyed the video. Have a great day.